So hello everyone and I welcome you all to APJ Academy where we are nurturing the young minds to become doctor and engineers just like you will become doctor and engineers in the near future. So in today's class what we are going to learn? We are going to learn the rotational motion. So I divided this topic in two parts. You know that this is a one short series in which we are covering in a very crisp manner, a very fast way. We are covering the whole syllabus of JEE mains, which you have to give in your 2022. Okay, so let me introduce myself before starting the class. But before that, I want you please rate the broadcast. That if everything is fine, then you can rate this 10 out of 10. And if you are feeling that my audio or video or anything you feel that it's not good, you can rate accordingly. My name is Manoj Kumar. I am physics faculty on APJ Academy and I'll be taking care of you and I'll be ensuring you that you will be more confident while attempting the questions related to the rotational motion, right? And I did my engineering from Delhi, BTech. I did my BTech. It's almost 9 years since in teaching line, and in these 8 to 9 years I taught in many renowned institutes online and offline, and I guided more than 1 lakh of students in online and offline institute, and this time I am guiding you. And I always says that my winners and losers have same goal. What does it mean? It means that when you are preparing for something, you always have one goal in your mind, that you have to crack this. But for cracking the entrance exam, you have to go through the process. The process is a marathon. In marathon, you might be running fast, you might be running slow, but you have to keep running in the same direction. So this is the motivation, this is the process which we will be following. And please subscribe this YouTube channel if you are, yes, balance game. If you are coming on the if you are for the first time on this YouTube channel, please subscribe this YouTube channel because we are providing fantastic videos here. And one complete full year course is also coming from APJ Academy where we are delivering you pre-study material, personal doubt solving sessions, full length test, assignment and DPPs, and we are ensuring you that you will be more confident while solving the questions related to the any topic. Means it can be physics, chemistry or maths, right? Or each and everything will be online mode. So let's start our journey. Let's start our journey of rotational motion. And before starting the rotational motion, we must be knowing about the center of mass. So what is center of mass? If anybody asks you that what is center of mass, then you can tell them that center of mass is basically a point. So that means if I am saying that center of mass is a point, that means I can locate this point, right? And for locating any point, we have our axis, x-axis, y-axis, we have the Cartesian plane, and if we are placing them in the three-dimensional, then we have our three axes, x, y, and z. So center of point is basically a point, so it represents us one point, and this is regarding the position, and this is the point where we can assume that the whole mass of the body can be concentrated, and if we are replacing the complete mass with that mass, right? So I can say that if this is my body and this body is having mass 60 kg, assume that this body is having mass 60 kg, right? And this is placed anywhere. I can, if I am assuming this body to be a point body, or if I am assuming this body to be a point object, then I can consider that this point will be having a mass of, this point will be having a same mass of 60 kg, right? So irrespective of whether the mass is spread or not, whether the mass is concentrated or not, when we are dealing with the center of mass, we will be concentrating on the fact that we will be considering only one point where we can assume that this is the total mass of the body, right? So these first point are very important. And in the first point, hello Tejas, hello balance point. Basically what I am saying that I'm explaining you the first point. In first point, I'm talking about two things. First one is the location. Second one is the mass. Location is a single point. Mass is a 1 point. So both of these are 1 point. The second point says that this is an imaginary point, means it doesn't really exist in the body. It might be inside the body. It might be outside the body. So this is our imagination, and this will be closer to the heavier mass, right? So if I'm going to make or if I'm going to concise all these 3 points, I can say that center of mass is a point whose location can be traced and whose mass will be equals to the mass of total mass of the body, right? So this is my first point, that this is a point whose location we will trace on x-axis, y-axis and z-axis, and the mass of the body can be that mass of that point will be considered as the total mass of the body. The second point is saying that this is an imaginary point. It's not like that we are having a point, particular point on the body where we can consider it. This is an imaginary concept, right? Third thing is that if we are assuming anything, then it will be closer to the heavier. So it's basically a mass digger. You might have heard gold digger. So this is basically a mass digger. So closer to the heavy mass. Assuming that I'm having a remote control here, and if I need to balance this remote, then how I could balance this? Will I able to balance this? See, I'm going at the midpoint, but I'm not able to balance this. It will fall. So I'm going here towards the heavier mass, right? This is not, I'm not able to balance this. Yes, it's going down. Explaining, okay, third point says that it will be closer to the heavier mass. I'm going to explain you with some examples. I'm going to explain you with these some examples. First of all, you need to understand that there can be only 3 types of questions which might be asked in your JEE exam. What are these 3 points? So center of mass, you must be knowing about the 2 particles. That what will be the center of mass if I am having the 2 particles? Then group of particles if there are so many particles. Then if there is continuous body, and if we are removing some body or something is moving, right? So this is how we are going to calculate, and I am going to explain you that what will be the formula, how we are going to calculate the center of masses. But before that, let's start how we are going to calculate the center of mass. Assume that I am having one mass. The mass is m1. This is mass m2, right? So for locating these masses, I must be having x-axis, y-axis. Now assume that this is my coordinate, this is my Cartesian plane. So x-axis and y-axis. So if I am placing these masses on this plane, I can mark this point as x1, y1. I can mark these points as x2, y2, right? Can I mark this? So if I need to find out the center of mass, then I should keep in my mind that center of mass is basically 1 point, right? Center of mass is basically 1 point. So how we can calculate that point? So center of mass formula is, for x-axis we have to calculate it differently for x coordinate, and for y-axis we have to calculate it separately, right? And if there will be z-axis, obviously we have to find out. So for x-axis, I can say that it will be x1 m1 plus x2 m2 upon में m1 plus m2. So if I need to find out the x coordinate of the center of mass, I can say this as xum. Then I will be saying that xum is equals to x1 m1 plus x2 m2 upon m1 plus m2. And if I need to find out the ycum, then ycum will be y1 m1 plus y2 m2 upon m1 plus m2. So this is how we are going to find out, right? And in the same question, we will be able to find out, we will be able to locate the point, right? We will be able to locate the point using this formula. Imagine that using this formula, we are getting point here, that here will be center of mass. So that coordinate will be xum, ycum. And what will be the mass of that object? What will be the mass of that point? Please do let me know. What will be the mass of that point? The mass of that point will be m1 plus m2. How many of you are getting this? The mass of this point is m1 plus m2. Are you getting this? The mass of this point is m1 plus m2, and the coordinate of xum and ycum can be find out using this formula. Xum x1 m1 plus x2 m2 upon m1 plus m2. Ycum is equals to y1 m1 plus y2 m2 upon m1 plus m2. So this is how we are going to find out. I hope this thing is clear to you. Now, if these things are clear to you, I'll be taking some more examples so that you will be able to understand how we are going to calculate. Assume that we do not have any axis. So here we have freedom to choose the axis on our own. So if I am having two masses m1 and m2, if I am having two masses m1 and m2, and these are separated by a distance of d, and I have to calculate center of mass, which I am saying it will be here. So I can take this as reference. So if I am taking this as reference, I can easily calculate. If I am taking the origin on any of these masses, I can easily able to calculate that where will be the center of mass. So if I am taking this m1 as reference, then this one thing will goes out, right? x1 m1 will goes out. Why? Because x1 distance is 0 here. So I'll be considering only the m2, the distance is d, and this is m1 plus m2. I hope that this thing is clear to you. Is this thing clear to you? Please do let me know. Now you might be thinking that, sir, how to calculate this thing? Assume that you are having one mass m here, and here you are having another object having 2m mass. They are separated by a distance of d, they are separated by a distance of r, let's assume. Then find out that where will be the center of mass. Find out where will be the center of mass. What will be the ratio of the center of masses from the distance m1 and m2? Find out, please solve this question. Balance point Tejas, and please share this session with your friend. And if you haven't subscribed this YouTube channel, please subscribe this YouTube channel. We'll be bringing more and more lectures for you daily, regularly. Live sessions are going to start on this YouTube channel. Please do let me know. Tejas, find out if mass is m, here mass is 2m, then what will be the center of mass? What will be the center of mass? xum. From here I can say that the ycum means the center of mass in the y-axis will be 0. It will only move in the x-axis. Y-axis will not move. So that's why I am only calculating the center of mass in x-axis, right? It might be that some of you might be thinking that why I am only going to calculate it for the xum. Yes, find out, buddy. Why you are in a hurry? So XUM is nothing. Here, if I'm calculating XUM is nothing. I know that the mass is 2m and the distance is r divided by 3m, right? So it's 2 by 3r, right? It's 2 by 3r from this side. That means the center of mass is more closer to the mass. Center of mass is more closer to the heavier mass, isn't it? Isn't it? Do let me know. Are you able to get it? Distance here is 2 by 3r. So it will be 1 by 3r. If I am going to calculate it from the 2m, then the distance of the center of mass from 2m is 1 by 3r. How many of you are able to understand this? This is like gold digger. You might have heard about gold diggers. Those who will be in the search of the person who are rich. So this is mass digger. It will be more closer to the masses which is having higher mass. So the center of mass is towards the mass which is higher in terms of magnitudes. So it is shifting towards 2m. Tejas skills balance point is this point clear to you? Shall I move? So I am moving forward. So here's one question for you all guys. The 2-point objects of mass m1 and m2 are separated by distance d. A student found out that m1 is greater than m2, then center of mass will be m1 is greater than m2, then center of mass will be near to m1, obviously. Center of mass always shifts towards the mass where he will get more mass. Center of mass will be near to the mass where he will be getting more mass, right? It's so simple. Let's move. So this is also a very good question, and you will find this question in multiple books. So two particles. So here we are having two particles of mass 2 kg and 3 kg are given to you. So this is m1 is equals to 2 kg, m2 is equals to 3 kg, right? So two masses are given and they are located at x is equals to 0 and x is equals to 15. So these two things are given to you. X is equals to 0 and x is equals to 15. Find the position of their center of masses. So you have to calculate the position of center of masses. Calculate the center of mass. Yes, calculate the center of mass. Where will be the center of mass? It's very simple, very simple. If you take this thing as origin, consider this thing as origin, you will get the answer immediately here. Please do let me know. As you know, even by checking the answer, you will be able to cross down at least two options. That if these masses are kept in x-axis, then the y-axis will be 0. How many of you are able to understand this? If these masses are kept in a straight line, then YCM is equals to 0. Then it won't be the answer. Right? Only two options are left. And I know that it will be shifting towards the distance is 15. So the midpoint is 7.5. So I know that the center of mass will be towards the what? The mass which is more. So center of mass will be towards where the mass is more. So this might be your answer. Even without solving, just by looking at the options, I can mark this question. Don't you think that only by looking the options I can mark this? If I know only three things about the center of mass, that center of mass is a imaginary concept where we assume that we are having one location in the body or outside the body or anywhere where we can assume that the whole mass of the body is concentrated on that one point. How many of you are able to understand? One. Okay. Now somebody will ask me that how, sir, you are solving this. So I'm going to calculate this for them. As I know m2 x2, so it is 15 into 3, and here it's 3. So xum is coming out to be 9. So xum is 9, yum is 0. So the option is 9, 0 is my answer. Right? Option 9, 0 is my answer. Let's move. And I think that I have to move towards this thing. Okay. Now, if you got some questions, are you able to see this? Yes. Now, if you got some questions where you are having mass m, 2m, 3m, and this side is A, this side is A, this side is A, and you have to calculate the center of mass, and you have to calculate the center of mass. So if you have to calculate the center of mass, then how you will be able to find out? It's pretty simple. Here we will be assuming one axis. Here we will be assuming one axis. Axis can be taken anywhere. We'll be taking here, so that distances can be measured very easily. Here, where it is going? We will be considering this thing. Okay. So this is the diagram we are having. Fine. This is the diagram we are having, and we have to calculate the center of mass. As you know that the center of mass formula is very simple. Calculating the center of mass formula is very simple. We have to just calculate x1 m1 plus x2 m2, right, upon m1 plus m2. Now there are three particles. So when there are three particles, we have to extend this formula to three particles, right? This is the only thing. So I am extending this formula to three particles, and ycm will be equals to y1 m1 plus y2 m2 plus y3 m3 upon m1 plus m2 plus m3. So this is my formula. Now, according to this formula, I must be having the coordinates of all these 3 points. If I am not having the coordinates of these 3 points, I am not able to calculate that what will be the center of mass. So the coordinate of this point is 0, 0, right? I am considering this as A, or I am considering this as x1 y1 and this mass as m1. So I am considering this as x1 y1. This is B point, and I am considering this B point as what? x2 y2. Then how you will be able to calculate the x2 y2? Only the great person, only the person who is having a very good knowledge, only the person who is having very good knowledge about the geometry and who was very good at class 10 will be able to answer this, that what will be the coordinate of this point, because as we know that this point will be exactly above the point from the midpoint, right, at a particular height h. So I can say that the midpoint, the x-axis, the x coordinate will be a by 2, right? Then what will be the y coordinate? The y coordinate will be What will be the y coordinate? It will be root 3 by 2a. How many of you are able to understand? How many of you are able to understand that for an equilateral triangle, the height is root 3 by 2a. Why? How? We are going to calculate this. Half into base into height. It's root 3 by 4 a square. So h is equals to root 3 by 2a. Okay, it's root 3 by 2a. So this coordinate is sorted out. Now the problem is how to get this c coordinate. So c coordinate, it can be easily calculated. It will be 0, no, 0, it won't be 0. It will be a comma 0. So it will be a comma 0. Then only thing which you require is to place all these values and you will get the answer. Now, how many of you will be able to solve this? How many of you will be able to solve this? Please, 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 please. Let me know the answer in the chat box. Please let me know the answer in the chat box. Please, 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 please. Let me know the answer in the chat box. I am giving you one more question. Yes, Balance Tejas. What is your name, Balance? What is your name, Balance? Find out, find out. Find out, find out, find out, find out, find out, find out. If you're not able to do, I'll do that. I'll be doing for you, baby. You do not need to take any tension when I am here. You do not need to take any tension when I am here. I'm with you, buddy. So x1 is 0, x1 is 0, so I can say that this thing is 0. The total mass is m plus 3m plus 2m, so the total mass is 6m. x2 is a by 2. So every answer will be in the terms of a only, right? So this will be a by 2. Mass is 3m. This x3 will be a. The mass is 2m. If I'm interchanging these values, 2m, if I'll keep the 2m here, 3m here, the center of mass location will change. Okay, keep this thing in mind. If anyone asks you that if you changes the coordinations or if you changes the places of the points in the center of mass, will the center of mass change? Yes, it will change. Definitely it will change, right? Because it will shift towards the heavier mass. So I can cut this m. You can say this, it will be 3a by 2 plus 2a divided by 6. It will be 4, 5, 6, 7a. It will be 7a by 12. How many of you are getting this? Balance point. Please share this video with your friends. This is very important because when teacher is teaching you and they want something from you, right? The only thing which you can give is hitting the like button, hitting the subscribe button, right? And sharing it with your friends and giving the inputs regularly so that you will be in the session only and you will not miss out here and there. Your concentration will be here. The only difference between the winners and losers is about the concentration. If you are having a very good observation skills, if you are having a very good concentration skills, then one day you will succeed and the day will come very, very quickly. Are you able to solve this? This is the point which is coming. And now let's move for the YCUM. For YCUM we have y m1 as 0, y2 s root 3 by 2 a into m2 is 3m plus y3 is a, it's 2m divided by 6m. M will cut, M will cut, and when this will cut, it will come out to be 3 root 3a by 2 plus 2a. I can write this as 4a and s12. Are you getting this answer? So this is my YCM, and the point is where the center of mass is located. So the center of mass is located at 7a comma 12 comma, oh, this is very complex value, but still you have to write this. So this is my answer. This is my answer. YCM is root 3a by 4. No, is it coming root 3 by, no. This is root 3 by 2a. The mass is 3m, so it will be 3 root 3 divided by 2, right? It will be 3 root 3 divided by 2, and here we are having 2a, so it will become 4a. The answer is correct. The answer is correct, Babu. The answer is correct. Okay. Now, if this thing is clear, in JEE exam, we will be having the center of mass for the continuous body. We will be having the center of mass for the continuous body, and for calculating the center of mass for continuous body, we have to do the integration, right? We have to do the integration, and only by integration we will be able to find out that what will be the center of mass, right? Without integration we won't be able to do that. So if I am having any continuous body, then I can calculate the center of mass of x coordinate by, then I can calculate the XUM by knowing the value of dm, right? So it will be x dot dm divided by root dm. This will be the way by which I'll be calculating my center of mass for the continuous body. And if this is having the extension in the y-axis as well, so I need to find out the y-axis as well, and if this is moving in z-axis as well, then I need to find out the ZCOM as well, right? So it will be Z dm under root dm. Write down these formulas. We will be doing some questions on this. Tejas, which type of emojis is this? Which type of emojis is this? Are you ready, my dear? Shall we move? So for continuous body, we have to calculate the center of mass using this formula. So these are the formulas which we will be applying, right? And I'll be showing you that how to apply these formulas while solving the question. So let's think that we are having one rod. I can draw the rod using the tools which I am having. So even you can draw. You have to draw on your own, but I am having the tools, so I'll be using the tools. I'm having the tools, I'll be using the tools. This is a very good thing. So this is my length L, right? The total mass is M. So I am having a rod which is having a mass M, the total length is L, then I can say that the length, if the length is L, the mass is M. Shall I? If the length is L, the mass is M. If I am considering a dx element, if I am considering a very small element, a dx, then for 1 unit of length, I'll be having M by L mass, right? So for dx unit of length, I'll be having M by L, dx unit of mass. How many of you will agree that for dx unit of length, the mass will be M upon L dx? How many of you will agree that for dx length, for this dx length, which we are having here, for this dx length, the mass will be dm and it will be M upon L dx. Yes, you all agree? Okay. So the first and foremost point is to calculate dm. I am writing the points here. I am writing the points because I believe that when students knows about that how to calculate and they know the points, then it is very easy for them to calculate these things. And if they do not have the points, then they will be looking for the teacher. They will be looking for the teachers when they were revising the concepts. So I am a type of a teacher who will be giving everything to you, and even without me, you will be able to solve the questions. So the step is, first and foremost step, whenever we have to calculate the center of mass for the continuous body, which is very useful for the IIT JEE exam, here what we are going to do is, first and foremost thing is calculating dm. So we have to calculate dm. So this is what we had already done, right? And once you are done with this, as you know that you will be moving from here, x length you will be moving, and you will be concentrating all these dx, and then you will be able to find out the center of mass. So the center of mass for the x coordinate can be find out using x dot dm under root dm. X dot dm means the integration of x dot dm divided by integration of dm. And we know that if we integrate, the total mass will come out to be m. How many of you will agree? And this dm, I can replace this as x m by l dx, and this dm will change to length, and I have to keep this. Please do let me know. Is everything fine, Tejas? You have to crack the JEE exam. Balance point. Is this fine? Now, we will not keep anything which is constant in the integration. This is our attitude. You can say this. This is our attitude. We will not keep anything in the integration. So it will come out. The m will come, the length will come. The only thing which will remain there is x dot dx, and the integration is from 0 to L. And this is mass m. We will cut this down. We will cut this. And the answer will be 1 upon L. The answer will be 1 upon L. The integration of x dot dx is x square by 2. Right? And we have to substitute the value of L. We have to substitute the limit here as well. So it will be 1 upon L square. Okay, 2 will come out. It will be L square minus of 0, right? Right, my dear friend. So it will be 2L square. It will cut down. It will come out to be L by 2. So XUM is coming out to be L by 2. And this is the answer which we were expecting, because this is the only thing which can come, right? If we are having a road, where could be the center of mass? It can only be at the center point. So this is what we were expecting and this is what we got. Please do let me know. Is this fine for you? Now let's move. Let's move to the next part. Please, if this thing is fine, please comment. If this thing is fine, please comment. Share some emojis. Come on guys, you have to crack the JEE exam. You have to get confidence. You have to be very excited when you are solving the question. And whenever you solve some questions, please shout it loud. Yes! One day you will become an IITian. This is the thing that you have to do. This is the best motivation which you can do on your own. There are only two types of person. I'm telling you, there are only two types of person. First, who is looking for motivation from outside. He'll be looking for some other person. He'll be looking for some other person to motivate him. And there are the second type of person is self-motivated. He won't look for other person. He knows that the only thing which he requires is to talk with himself only. And the only way to be the self-motivated person is to write the goals. Write the goals which you are having. Right? Because only by writing the goals and having the SMART goals, keep your SMART goals ready. What are SMART goals? What are SMART goals? You must be specific that which IIT you have to go. SMART means specific. The goal must be specific. It's not like that you want to go to the IIT. Which IIT yaar? At least you must be knowing that this is my IIT. Which branch? Right? So, specific thing. It must be measurable. It must be measurable. You must be able to measure the thing. You must be able to measure that whether you are going for the goal or not, whether you are at the right direction or not, you must be able to measure that thing. A defines for be specific, measurable, achievable. It must be achievable. If the goal is not achievable, no one wants to go for that goal. R is relevant. It must be relevant for you. And T stands for what? Please do let me know. T stands for time bound. It must be time bound. If you keep on giving them big time, if you increase the time, the work will stretch. You won't be able to do that. And this might be the thing which you might have seen in your life. Right? So let's solve the last type of questions in the center of mass, then we will move forward. The next type of questions in the center of mass is where we are removing some part. Where we are removing some part. So here we are removing some part. So where will my center of mass shifts? This is the question. Where will my center of mass shifts? This is the question. So the answer is very simple. The answer is very simple. If you are removing some area, assume that this is the area 1. This is the area 1 having its center of mass at this point, which is known as x1 y1, having its center of mass at x1 y1, right? So we have center of mass of area 1 which is having its center of mass at x1 y1. Now assume that you are removing one part. You are removing one part from here. whose center of mass is x2 comma y2 and whose area is a2, and you are removing this part, then what will happen? Your new center of mass, your new COM, as you know that center of mass for x-axis, y-axis will be different, right? This is thing which you already know. The center of mass for the x-axis and the y-axis is different. This will be x1 a1, right, minus x2 a2 upon a1 minus a2. This will be y1 a1 minus y2 a2 upon a1 minus a2. So these are the things which you have to keep in your mind, and we will be solving one questions on this. Please write this down, and if everything is fine, please give me emojis. These are very important because these help me to keep myself motivated, and this help me to keep you motivated. And do share this session with your friend. Are you able to get? Are you able to get the answer? Okay, let's move. Let's move, rockers, the toppers. So now we are moving, and now imagine that I am having a continuous body, which is a circle, which is none other than a circle. Oh, I can draw the circle for you. So this is the circle, right? Without any tool, I draw this circle for all you guys. Now, I'm having the coordinates. So this is my coordinates. As you know that this circle is having radius r. The coordinates here are 0, 0. Right? This is having a radius r. The coordinates are 0, 0. And as you know that if this thing is having a continuous density, uniform density, then the center of mass will be lying at the center only. And now what you did is you remove one part, you remove one area from where, let's consider this from here. From here, you remove this part. Now you are removing this part. Oh ho, we are removing it. Okay, now as you know that this is having a radius r, and if this is having a radius r, we are removing basically this area. We are removing this area from this circle. We are removing this area from the circle. Okay, we have removed this thing from my circle, and you have to find out center of mass. You have to find out the center of mass, new center of mass you have to find out. And as you know that if you are removing this thing, as you know that if you are removing this thing, then what will be the radius? That must be r by 2. That must be r by 2. Right? That must be r by 2, r by 2. This radius was r. So what will be the center of mass? What will be the new center of mass if I am removing this area? If I am removing this area, then what will be the center of mass? Are you getting the question? Okay, headache. Balance point Tejas. And do subscribe our Telegram channel, which is given in the description. And tomorrow we are having a class on Newton's laws of motion's previous year question. Okay, I'll be covering NEET. The class is on NEET previous year questions, but I want you all to please join that class because that will be very helpful for you. Please do let me know if I am removing this, then what will be my answer? I already gave you the formula. I already gave you the formula that these are the formulas which you have to use. Okay, these are the formulas which you have to use. I can take this formula here. These are the formulas which you have to use for calculating xum and yum. And if you are seeing that the first center of mass, I am having one area, right? The area A1 here, if I am writing this, the area A1 is pi r square. The center of mass, the x1 is 0, right? Y1 is 0. So I know that x1 and y1 is 0, 0. How many of you know? It will be obviously at the center of mass. So this thing is very much clear to everyone. And now what happened? The area 2. The area 2 of the object which I am removing, the area 2 of the object which I am removing is pi r square. What will be the radius? R by 2, right? So it will be pi r square by 4. So this is the area. And what will be the coordinates here? What will be the coordinates? What will be the x2 here? Obviously the x2 will be, because I have to calculate the center of mass of this object only. So the x2 will be a by 2 and y2 will be 0. Why 0, sir? Why 0? Because you know that the same mass removed from top, the same mass removed from here. So the center of mass will remain same. How many of you agree? Agree, my dear. Agree, my dear friend. So I know that now it become very easy. It's become very easy to calculate the center of mass. Now it's become very easy to calculate the center of mass. So xum is equals to x1a1. I know that this will be 0. x1a1 because this is 0. So I will be saying that this will be, I'll be changing the color. Why? Because it will look nice if I am having some different colors. So xum is this. Area 2 is pi by 4 r square, pi by 4 r square, and x2 coordinate is a by 2 divided by a1 minus a2. So a1 minus a2 is pi r square minus pi r square divided by 4, right? So this is how we are going to calculate. So now we have to calculate xum. Now continuously, if we will solving this will become 4, and I can cut this 4 with 4. I can cut this r squares from here, and it will become pi a by 2 minus divided by 3 pi. Okay, pi will cut obviously, minus a by 6. How many of you are getting this? How many of you are getting this? That xum is equals to minus a by 6. This is the correct answer. This is the correct answer. And the new center of mass, is minus a by 6 comma 0. It's clear, my dear. Here we are removing some area. We are removing this area. We are having one area, right? And we are removing one part from the circle and we are calculating the new area. Hello, headache. Yes. So I hope that everything is clear to you, my dear. Now, in the next class, as I already told you, that we will be going for the Newton's laws of motion, and in the rotational motion, we are done with the center of mass. Now, some of you might be asking that why center of mass is required. Some of you might be thinking that why center of mass is required. Because our mechanics, if we have to study the mechanics, and we have to apply the mechanics in real system. Real systems are extended bodies, right? We are having the length, breadth, height. So how I will be able to apply the kinematics, how I will be able to apply the mechanics, which is written only for the objects which are point. So scientists thought about one method, and that method is the center of mass. So what we are going to do is, we will be calculating the center of mass, and we will be applying all these rules whichever we had studied earlier on these objects, just by replacing the total mass, total configuration of the object to one point. So the each and everything will become same, right? So this is the thing, because mechanics is written for point objects. So that's why points are very important. And in the next class, we will be doing that, how to calculate the torque and everything. We will be doing in the next session. And before we proceed, I want you all to please join our full year course, because with this course, what you are getting is just amazing things, because you are getting the complete modules now, and this thing with a very, very low price. Check the description box and join our Telegram group, so that you will be able to join a community where you will get each and every question solved within few seconds. The test series comprises of 25 major tests. The query solving sessions are there, and these query sessions are not like any other institutes, because here we are providing a personal assistance. Personal one-to-one doubt clearing sessions are here, and assignments after every class you will be getting. And all these lectures are in a very structured manner. Just like in today's class, I completed the center of mass. I completed all the theories related to the center of mass, that what will come first, what will come second, what will come third. And you will be getting the study materials, free test series, free notes, free question bank, and the price is very low. Price is very, very low. Means it is very low as compared to all the online courses which is available on the internet. So you have to join the ALT JEE. The PDF materials you will get here on this Telegram group. So if you haven't joined this, please join this ALT JEE Telegram. PDF materials you will get, free classes, announcement, discount, and prizes you are getting. Okay, please join this after the class. And this is basically a crash course. If you have to appear for JEE 2022, then these are the classes which you must not miss, because in these classes we are covering whole syllabus of JEE, which is totally free of cost. Also, if you want additional sessions, if you have some doubts related to some topics, then you can join our paid course as well, where we will be assisting you. We will be assisting you personally. We will be clearing all your doubts personally, and we are using the flipped classroom method there. What is flipped classroom method? We will be providing you theory class. We will be providing you first with a very concise one-shot video of theory. Then after going through this theory, you will be going through the study materials which we are providing. This is obviously free of cost we are providing. After this study material, you have to go to the webinars which we are conducting. And on this webinar, we will be taking your personal doubts, right? Like if you are not able to solve the center of mass questions, so we will be taking those center of mass questions which you are not able to solve. Obviously, some questions are there which would be able to, which anyone will be able to solve, and some questions will be there which no one will be able to solve. So we will be considering all these questions and homework will be checked. You know that why the student fails? Because they lack in the homework, because nobody checks. Here we will check your study homework regularly, and as I already told you that I am very happy to announce that APJ Academy's full year course is running, and the complete full batch course is running on, and you can join it, right? It's starting from 1st of June. So you'll be getting the free study material, percent doubt solving session, full length test, and many more things you'll be getting. And this is not the end. This is not the end. You will be also getting all these things which I already told you. And if you are believing that you will be able to crack the entrance exam on your own, then I must say you that you must not take risk in two things. First, when there is a risk on your life. Second, when there is a risk on your career. Everyone requires coach. It might be that you are taking the paid coach, or it might be that you are taking it as a free coach. So even if you are taking me as your free coach, I'll be assisting you at every point of time, and I'll be providing you a calendar schedule. What is calendar schedule? The calendar schedule is nothing but a complete schedule on which we are taking the classes. So with the calendar schedule, you will be getting more consistency. You will be getting more motivation, right? Because for consistency is the most important thing. It makes your habit. First you make habits, then habit makes you. That's the old quote. Then once you are consistent, you will become more confident. You will be able to solve more challenging questions, and your capability will also improve. Right? And yes. Radius of gyration, we will be considering the radius of gyration Purva in the next class, where we will be considering the moment of inertia. Only after clearing the moment of inertia, I'll be teaching you the radius of gyration. It is nothing. You just have to compare the radius moment of inertia of any object with the moment of inertia of ring, right? You just have to compare the moment of inertia of any object with the moment of inertia of ring, and the radius which you are getting is the radius of the gyration, right? So we will do that in the future class, don't worry. I'm telling you that APJ Academy is providing you the structured course, free study material, and all these things. The main advantage of all these things are that you can buy them separately as well. If you want only the structured course from us, you can buy them separately. If you want the test series, you can buy them separately. If you only want the study material, if you only want the personal doubt clearing sessions, you can buy them separately. The payments modes which are available are all online mode. Part payments are also available for you, and there are also personal mentoring one-to-one sessions which are running currently for all the students who are enrolling now with using my code, which is Manoj JEE. Right? So that's all in this class, and please join our Telegram channel. Don't miss that. And don't forget to use code Manoj JEE. Whenever you are taking the subscription, tell that you are taking the subscription just because of your physics teacher, which is me. Right? So let's end this session here. Bye bye. We will meet